calculus. And you go, yes, we're there. Because you've heard how incredibly amazing calculus is and how useful it is in the real world.
It is very useful.
It is very useful in the real world. For those of you who've been in physics and been watching Mr. Silbert's videos with the Shazam magic that happens, that Shazam magic is calculus. He has these physics videos and then things happen and it produces an answer. It's actually calculus that's happening because my calc students are sitting there going, oh yeah, it was integration or whatever it is. So calculus has many, 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 many uses. There are actually three major parts of calculus. You learn limits, you learn derivatives, and you learn how to do integrals. I am recording this.
Hi Ken, hi Mallory, hi Eli, hi Justice, hi Caleb. Hi to all of the ones that Sal said.
Okay. We are going to learn the basics of limits today. We're going to learn only the basics of all of these because it happens to take me a whole year to teach all of this otherwise. But limits, you can't have derivatives and integrals if you don't have limits because everything is based from the limit concept. So that's the major thing we are doing today. We're going to touch a itty bitty bit of derivatives today, and then we'll kick into more derivatives next time. So the big question is, when I talk limits, what on earth am I saying? And first of all, you have to learn to read the notation. Notation in calculus is critical. You will write the notation as shown. You will not shortcut the notation. You will lose points if you do shortcut the notation. Okay? So make that clear. You ask the calc students if I am really, really, really anal about their writing their limits correctly. So what they're actually saying here, when you find a limit, limits are concerned with what a y-coordinate of a function is doing as your x-coordinate gets close to some number. The whole thing is how close they are to some number. We are never concerned with what happens right on the number.
Why?
Because that's not what limits do. Limits are concerned with what happens as you're approaching a number. As you're getting really close to it, you're asking, what is my y-coordinate getting really close to? And you'll actually see a couple times here, I will get to show you where the limits actually matter in the next few days. So when you read limit notation, every problem will have LIM, and below it will be x approaches some number. Now, you'll notice I have three in a row here, all approaching -3. One has a minus behind it, one has a plus, one has nothing. That matters. If it has a minus behind it, it means you're approaching from the left side. So you come toward -3 from the left side. So we'll see if we can figure one of these out fast.
This is going to make a lot more sense here than it did in college algebra.
Okay. Our college algebra students, for those of you listening, has already seen some of this. So -3 is right here. What I'm saying is my x-coordinates start to move toward -3. Where are my y-coordinates going? So if I'm out here, my x-coordinates clear up here, or my y-coordinates clear up here. If I move over, then my y-coordinates coming down. And as I keep getting closer and closer, where are my y-coordinates homing in on? +4. Doesn't matter that there's a hole there. We only ask what's happening when it gets close, not what's happening right on it. So we would say the limit from the left is +4. Okay, but it's lunchtime, so then we'll pause and we'll come back and talk about the limit from the right. Aha. Okay. So, one more time, what does it mean when I say, Isaac, keep your hands to yourself?
Oh my gosh, you are children.
We'll try again. So, what does it mean when it says the limit as x approaches -3 with a plus sign on it?
Coming from the right.
You are coming from the right side. And some people try to think it means go right. Not the case. Start on the right side and come in towards -3. So if we get over here to the right of -3, and you have to, how do you know which piece of this graph you're following? Should I be following this curve clear out here to the right?
No.
No, you're finding the graph that's directly above or below the point you're at. So we need to find, okay, straight down, we'd be down here. And as I start to move toward -3, as my x-coordinates move to the left, I'm going to find that my y-coordinates are doing what? they're getting closer and closer, particularly as I get up here toward the top, we get very near -3. My y-coordinates are once again going to the magical number 4. Okay, so the left and the right side turned out to be going toward the same number. What does it mean when it says x approaches -3 and there's no little plus or minus behind it? That means from both sides. So if you came from both directions, left and right, what number is it? It's in this case, because we already know left side went toward 4, right side went toward 4. That means, yes, from both sides, it's going to be 4.
Should I be like a parabola?
Yeah. Well, it could be, and it's this point. Even though there's a hole, actually, at this number we're looking at, the left and the right sides are still coming toward the same point. So we have a limit from both sides. Okay. Then, finally, they're going to ask you, what's f of -3? Notice, not a limit.
There's a hole.
Okay. Because what does it mean when you say, what's f of a number?
Nothing. What
What's
function?
the
What's
y?
Because f of x is the same thing as y. So they're saying when you put 3 in for x, what's y? Excuse me, -3 in for x. So it's asking you when you are exactly on -3, smack on -3, what's the y coordinate?
4, -3, 4.
If you write 0, you're saying it's down here 0.
Not applicable.
Well, you're guessing in the right term. There's a term for when there's no value there. We used it before.
Unequal.
value.
Uneven.
Undefined. There we go. So, yes, it's undefined when there's no point there. So the limit can exist. We had a limit of 4, but there's still no point there. And that's what's kind of cool about it. The limits care about what happens when you're close, not when you're right on the number. So let us approach another one here. This time we're going to tackle -1. So if I try to approach, +1. If I'm trying to approach +1 out here, +1 is over here. We've got +1. So as I approach, once again, 1 from the which side?
The left.
Coming from the left. I'm coming in toward 1 from the left side. Where is that graph going? It's going down, 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 and it's getting really, this side of the graph is getting close to -6. But when I do 1 from the right-hand side, and I come in this way, I'm now following this piece over here, so my y-coordinates are coming down, 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 and going toward -7. So then, what do you say when I ask you what's the limit from both sides?
-6 and -6.
Do you average them? Do you say both of them?
None.
To have a limit from both sides, it has to be going, both sides have to be going toward the same point. Is that happening here?
No.
These are not coming, we don't call it undefined in the land of limits. There's a technical name for it. The shortcut way to write it is DNE. What do you propose?
Does not exist.
Says it right
Yes.
there.
Does not exist. And yes,
So in terms of a graph, a limit does not exist when?
a limit does not exist when what happened?
When it's
Whenever it
The left side and the right side do not agree. Yeah, they don't. When the left and the right side are not approaching the same point, it does not exist. And the dead silence is because they're all writing on their journals. So, what is the value of the function right on 1 this time? When you are at +1, what is the y-coordinate? Where is the filled-in dot? That's what you're looking for. In this case, it's at -6. So, can't be. It's not a function. Wouldn't pass the vertical line test. Wouldn't pass the vertical line test. Wouldn't be a function. These have to be a function. So, that won't happen. So, let us try a really interesting one. Let's go out here and look at +6. Out here at +6, we got some asymptote action happening. So, if I'm coming toward +6 from the left side, and as I get in here close to +6, where are my y-coordinates going? They're going up higher, they're going up higher. As I get closer and closer to 6, I'm going to continue to get closer to the asymptote. So do you all agree, or am I going to positive infinity? It's going to go right up that asymptote. Okay, what about 6 from the right-hand side? Yes, now you're following this piece. It's going down, 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 and we would indeed be heading toward negative infinity. So what do I say the limit is from both sides?
Does not exist.
Does not exist. The both sides one, it only exists if you got the same answer on the first two. So if those two didn't agree, it's automatically, it does not exist. And then last but not least, what's the value at? Why?
Because it can't touch the asymptote.
There is no point there. Actually, this one is undefined. It would not be incorrect, and sometimes they will do this. You can have, they can just have a point sitting right there on the asymptote. You can have a point defined there. It's kind of weird, but it can be done. And it still passes the vertical line test. Will they do that to you? They might have. I don't remember if I was that mean on that worksheet or not. So that white worksheet I gave you, that's all you're doing is looking at the graphs and figuring out the limits.
So wouldn't that
That's already
change
higher,
the,
No, that's not
linear,
yet.
wouldn't that change all the answers then?
Nope, because this was 6 as you're getting close to 6. The limits were all when you're getting close to 6. That one only applies when you're right on 6.
I like the shirt, Mr. Mine.
Thanks. Random, but okay.
Very nice.
Thank you. K installation tonight, had to stiff up a little. Okay, no, we don't want that. We're gonna go from scratch here. Except I don't like that color, never mind. We're gonna wipe this out. Okay. So, you're going, but gee, most of the time in math, they don't give me a graph.
Gotta make your own graph.
Most of the time they give you the function written out in X's and symbols. How you find limits when they give it to you as a function in symbols. Calculator, are you kidding?
No.
You could graph this, but why would you? There's an easier way. On this there is. Okay, suppose I said find me the limit as x approaches 2 of the function x squared plus 1. Nice easy function. Okay, that is a problem. Shifted where? So we could actually draw a really quick picture of this one. If I'm up 1, and then I know I would be 1, 1, 2, 4, etc., as far as plotting points from that vertex. So, looking at the graph, what is the limit from both sides as you approach positive 2? If you come from the left or you come from the right, where are you going to be at when you're at positive 2? You're going to be right, you're coming toward this point either way. But that, if you count, that's actually 5 units up. So my answer's got to be 5. Now tell me how I could have got 5 as an answer without the graph, just looking at the original problem. Yeah, you could have put the 2 in there. 2 squared plus 1. Well, as long as it works, it's great.
What? Does it ever not work?
Yes.
Oh, what the?
Many times it does not work.
So why are you teaching us?
Because I'm going to show you what you do when it doesn't work. Okay, if you put the number in and you get a value, it works. You'll get strange answers. I'll show you here in a second when it doesn't work. But yeah, that's the first step of doing a limit. If you're doing a limit problem, you just put the number in and see what you get. If you get a normal, some numerical value, that's an answer, you're done. But
What do you consider normal, like a whole number like that?
It could be a whole number, a fraction, a square, any real number. As long as you get a real number as an answer, you're good. As long as you don't get infinities, and well, we're not going to see infinities this year. But I'll show you a couple here shortly that do that. I have that piece of paper here. So let me show you something that might potentially be a little nastier.
Yeah, you're very short on time.
I am? Oh, I am. Okay, we'll stop. We'll pause while I write.